And welcome to session number 3 of the Lubbock evening. It is my pleasure to introduce Professor Malcolm McCulloch, who is an Associate Professor of Engineering Science at the University of Oxford, Group Leader of the Energy and Power Group, and a Tutorial Fellow at Christ Church College. He was previously co-director of the Institute for Carbon and Energy Reduction in Transport and a member of the Oxford Martin School from 2008 to 2013. Malcolm's interests are the areas related to domestic energy sector, development of user-centric, demand-side management technologies, and useful information to enable behavioral change. Research is ongoing on the development of powertrains for electric vehicles, novel lightweight, low-speed, direct coupled generators, a transverse axis tidal turbine, and technologies that leverage advanced intelligence to enable cost-effective nano and microgrid solutions that provide a scalable pathway to distributed electrification. He has founded 3 companies, all leveraged by these exciting technologies. The title of his presentation is The Duality of Sustainability in the High and Low Income Countries with Reference to Energy. Malcolm, I'm going to hand it over to you. You get 15 minutes for your presentation, followed by about 8 minutes for questions.
Thanks, Ron. So good evening, everybody. So tonight, I want to talk about sustainability, but I want to make sure that I recognize all the fantastic people that have helped me to put together the material that can enable this talk tonight. Those both members from my group and also some members from Professor Dan Rogers' group. So sustainability is one of those words which has a challenging life in trying to be defined. And so the particular definition that I'm going to be looking at is in terms of capitals, and particularly 3 types of capitals. The first one is that of people, the second is of planetary resources, and the third one is of prosperity or financial capital. And each of these capitals are used to be able to execute and do stuff. However, they're not all exactly the same. And what we realize is that in society, we've basically been using financial capital to be able to translate planetary and environmental capital by extracting largely finite resources to create additional human societal capital. Just look around you and you'll see all the different natural resources that have been used to create a better lifestyle for you. And one of the outcomes of that has been that society tends to dump its waste back into the planetary capital, back into the planet. And what you're recognizing is that this is no longer a viable way to go forward. We've got to think about how do we actually both increase our planetary capital and our social capital. For this discussion, I wanted to have a quick look to see how are the different countries in the world doing in terms of the planetary capital resource extraction and the development of Human Development Index. So this graph plots every country on the planet, and on the right, on the horizontal axis is basically the global hectares required per person for that particular country to support their lifestyle. And the vertical axis is the Human Development Index, which is kind of an indicator of that social capital. If we look at the ecological footprint and we take the total global hectares that are available to sustain life, and divide by the total number of people on the planet, we get to a number around about 2. So in order to be sustainable, we need to be left to that curve. It's also generally recognized that you want to be to have an HDI of around about 0.8 and above. And we can see this is kind of like the target space that we want to get to. The challenge for this century is basically to enable these countries to move leftwards and these countries to move vertically. And if you have a look, you can see that these top countries are the high income countries and these are the low income countries. And often these are seen as 2 separate agendas, but I posit that actually we're on the same we're heading towards the same place, just the journeys are going to be slightly different. And I want to take a idea around energy to show how the journeys are more similar than we might otherwise anticipate. So if we have a look at a similar mapping, but now in terms of energy consumption, this is mainly around electricity. The horizontal axis is the consumption per person per day. The vertical axis is renewable generation over consumption. And then the color is what percentage of the population has access to electricity. And the size of the bubble is the size of the country. We can see again, there's a mixture that we have. And typically what we're looking to do is that we need to have a target zone in this kind of area here where most of the renewables most of the generation is from renewables, maybe slightly larger such as Norway because they use it for export. But the key thing is that you're looking for something between 10 and 100 kilowatt hours per day per person. So again, we can see we've got two separate agendas. The first one is to see we've got these low-income countries. They basically need to have improved energy access. So in other words, using energy to improve quality of lifestyle. And these guys here need to be able to decarbonize their energy. In other words, taking less from the planetary resources. So I'm first going to look at these two and take some case examples just to show how they might be similar. I'll start off with the energy access agenda. And this is a satellite photograph of an area we're working in Kenya. And you can see one of the challenges is that every yellow dot is a location, and you can see they've really separated out over quite large distances. And the second issue is if you have a look at the typical places where people live, you can see that they definitely are not on the wealthy end of life, and therefore are very conscious of spending any money, and especially capital, in order to improve their lifestyle. So we need to enable a system that can have a large and low-cost distribution network, as well as being low cost, to enable it to be affordable for the participants. And just like Dave showed, with batteries coming down dramatically, we've also seen solar prices are coming down. This is a graph I keep track of, and over the last 10 years or so, it's been averaging about 18% decrease per annum in the cost of solar modules. And you can see here, this is an example of a solar module that's been deployed in Kenya, and we need lots of sunshine to make the solar modules work. The problem is that when you actually look at the utilization, it's largely at nighttime, where people are using it for light and for other activities once they come outdoors. So the question is, how do we get energy that's produced in the day to be able to be used at night? And all those who've watched Dave's wonderful presentation will realize you need an 18650 battery in order to be able to store the energy and basically move it from the day to the night. Now that's led to a particular insight, because normally we put batteries where the generation is, but what happens if we put them where the load is? That gives a particular insight. We see that if batteries are in the home, basically we can now use the grid to charge the batteries. You don't have to use the energy down the line to produce the service at the point of time it's used. We can use it rather to charge the batteries up. And if you use some power electronics to compensate for voltage drops of really thin lines, it means we can end up with a low voltage DC line, which is very low cost. The low voltage is important because that means that it's no longer lethal, and so therefore you can change you can allow for community install, which removes a significant cost. And again, the cost in line is important because we've got those longer distances to be able to travel. If we stand back a little bit, we realize that in the batteries are all about shifting energy and time, but they have a direct impact in creating value in the spatial design, in other words, the layout of the grid. And this is kind of an interesting philosophical concept, that grids now have to take both space and time into account. So the concept we took from that idea is developed into a program called Railcon, which is low-cost grids. And basically we can see we have some power electronics, we have a long line to a central generation, we have a local battery, and basically we then provide 12 volts output to provide the low voltage requirements for the services that people require. We can see we basically would have a central hub and basically individual lines going to each person. The reason we can use individual lines is because diversity in terms of load is no longer as important, because of the storage flattens the load out. And then we can scale up to larger grids if we wanted to. So that looks like a great idea. Where are we at the moment? So if you look on the right side, there's our power electronics. It sits within a board with our battery pack. And we've at the moment got a mini grid of 10 of them that are being under test at the moment and will be deployed out to Kenya at the end of next month. So that showed that energy access gives us particular challenges. Now, what about decarbonizing? What are the challenges we can learn from that? So clearly we've got to move from our coal-fired power station, and this is, some of you might recognize this was Decarbonising power station as was, no longer exists, but we have to move from that basically through to wind turbines, or to the earlier talk, to tidal turbines. But also we have to change the way that we actually power a lot of devices. We've got to move from gas to electricity and hydrogen for heating. Our vehicles are moving from electricity all the way from petrol. And we've got various hot water now needs to be done electrically as well. So if we look at a simple analogy of what used to be the grid, is we had central power stations, we had a transmission network which moved energy through space to the end consumers. Then basically a retailer would pick money up from them and say give them back to the members of the distribution, member of the power system to pay for their services. So if you think about it, what we're going to be doing is we're swapping out the coal for generation and for renewable generation. We're also adding a lot more load onto the system. And that basically means we have a lot more power going through those lines. And the challenge that we want to do is we want to stop that from happening. So the way that we can think about this problem is to say that the lines need to carry more energy, but reinforcement is really challenging. We don't want to be digging up the roads or putting new transmission lines out. It's really challenging to do. So the way we do that is by flattening the peak powers. And the way we can flatten the peak powers, and we need to flatten quite a lot of it, is to basically create a market to enable different actors to shift the power in time. So if you look back to the insights and what does this lift when you stand back again, here we got a challenge around spatial operation, in other words, lines carrying more energy, and we are creating value in shifting in temporal. So we see that once again that the spatial temporal play not only works in the developing world, but also in the developed world. So how does this change our picture? So we had that network services, that's how we conventionally think about it. Now we basically have to move to thinking around balancing services as well as looking at moving energy through space. And a particular outcome that we've been looking at and how to do this is a project called Project LEO, which is, LEO stands for Local Energy Oxygen. And there's a group of us, including the distribution network operator, community energy companies, some of the large energy suppliers, as well as our local local authorities, all coming together to reimagine what a local energy system would look like. And in particular, we're looking at how do we actually mitigate the consequences of increased loads on the system, and how do we create a market that creates that. And if you have a look here, this is a centric hydro to run a river hydro station. And basically what we've now been looking at is how do we actually use the river to actually store energy. So the plot on the right hand side, the green plot is the river height. And you can see that we turn, and the blue is the power. So we turn the power of the turbines down. Basically the river rises a few centimeters, and then we basically release the water, and we can now provide additional energy at a peak time. And so this is now using the river as a storage resource to provide that temporal shift in energy. But also, we're not only looking at large assets, we're also looking to say how can individuals become part of smart and fair neighborhoods, so that normal people like you and I can access this energy revolution and actually prosper from it. And so this actually brings us to a nice conclusion, because what we're realizing is that we need to take fewer resources, and especially fixed resources, and move to renewable resources and shift them over towards people. Decarbonisation, like we've just been talking about, is mainly concentrated on the planetary side, but also it's concerned about equity around people. And we also noticed that when we were concerned about access, which is largely about equity of access to normal people, we're actually using a decarbonising technology because that was the cheapest. So my final conclusion is just the little brain in the middle, which says is that all of us need to come together with our different skills from our different situations and learn from each other so that we can actually create a viable and thriving planet. Thank you very much for your time.
Well, thank you, Malcolm. We do have a question.
Yeah.
I'll read it for you. It says, does a low voltage system assume limited end use, i.e. lighting and other low power devices rather than pumps, heaters, ovens, etc.?
Okay, so we're looking to be able to move something like between 300 and 500 watts. And that may not sound a lot, and yet we're also got a number of projects where we're doing cooking on 400 watts. And we're doing that by looking at highly insulated, well-controlled cooking pots, which allow us to basically cook the typical staples that we will have in Africa on a very low voltage, well, a very low power requirement. And so even though it is low voltage and you would think that the lines are going to be challenging, we can still do cooking. And that just one of the reasons why we want to do cooking is because a substantial amount of forestry destruction is because of the overuse of wood for cooking. So this again will have a substantial environmental impact if we can get that right.
Okay, I have a question. You talk about reimagining power delivery in Oxfordshire. To what extent does that reimagination constrain in a practical sense by the fact that we may have to do significant infrastructure improvements in order to achieve that? Is that factored in, or do you just assume that anything can be built that needs to be built?
So what we're trying to do, Ron, is build as little stuff as possible. So basically what we're looking at doing is being able to use our grid a lot more effectively so we don't have to do the rebuilding. And what we typically find is that, say, between 5 and 7, most of the losses happen in the grid. So if we can actually shift the energy for earlier on or different times, we can actually pump a lot more energy through the same grid because we don't have those peaks in power where all the losses come through. So the whole idea is to try and maximize the amount of utilization of the grid without having to put a lot more assets in. The assets we are going to have to put in is on the generation side, and that's just going to be inevitable because of the commitment that this government and other governments are making to decarbonize the system. That's going to be critical.
And how much of the impetus for changing the way we do things in these communities driven by the fact that the government needs to figure out a way to charge cars relatively soon, because right now the capability of doing that is pretty limited. It seems like we have a lot of ground to cover.
Yes, charging cars is going to be challenging, and what's interesting is we've done quite a lot of work in this space. And at first point, okay, so if people just charged cars when they came home and just did things normally, we would need something around about between 15 and 18 gigawatts of extra capacity in the evenings. And that's equivalent to something like 8 to 10 nuclear power stations. So that's a lot of extra energy or a lot of extra power that's needed at that point. However, if you do it smartly and you basically shift the energy when you draw from it so that you still get the mobility requirements in the morning when you need to go, basically you'll need something like 500 megawatts more of additional capacity, simply because you smooth out that curve a lot. So if you do things smartly, you can actually get a lot out of the system. And the challenge that we have is that basically because fossil fuels have been so cheap, we haven't had to think that hard to actually get the service we want to. We now have to think a lot harder to be able to get the same service.
Okay, so if there are no other questions, I'm going to once again thank Malcolm for a very interesting talk, and we'll bring this session to a close. The final session, the featured session for the evening, is going to start at 7:55. So I guess we'll see you all in about 10 minutes. We have about a 10-minute break we're looking at. Thanks, Malcolm.
Thank you, Ron.